Welcome to the deep dive. Today, we are strapping on our virtual helmets and peering into the catastrophic history of 79 AD. We're focusing on the shadow of Mount Vesuvius.
It's such a famous event, isn't it? The disaster that really defined our picture of Roman life. But for you, the listener, we want to drill down into a fascinating paradox.
A paradox.
Yeah, the mountain simultaneously destroyed two cities, Pompeii and Herculaneum, yet it preserved them in, well, completely opposite ways. It's quite remarkable when you look closely.
Right. Everyone knows Pompeii. I mean, it's the big one, the vast city, frozen solid, famous all over the world for those haunting plaster casts of people.
Exactly.
But we're doing a deep dive into its neighbor, Herculaneum. It was smaller, definitely wealthier, and maybe far more mysterious. We really want to understand the physics of destruction.
That's precisely our mission today. To explain why the fate of these two cities wasn't just terrible luck, but a result of very specific scientific factors. Things like wind direction, heat intensity, the type of volcanic material, and crucially, timing.
Okay, so we need to figure out what exactly led to Pompeii giving us those empty spaces, the voids that became the casts.
While Herculaneum, on the other hand, gave us perfectly preserved organic material. We're talking actual wood, food, fabrics, and even, incredibly, the only surviving library from the ancient Roman world. How did that happen?
Let's get into it. To really understand the differences in how they were destroyed, maybe we first need a snapshot of who they were before the eruption. What was life like? Let's start with Pompeii, the big city.
Right, Pompeii was definitely the powerhouse, the economic engine of the region. A pretty sprawling place, covering all 67 hectares. Population estimates vary a lot, but maybe, 10,000, possibly even up to 20,000 residents.
So a significant city for its time.
Oh, absolutely.
Yeah.
A major commercial hub. Pompeii was vital for trade, exporting huge quantities of local products like wine and olive oil across the Mediterranean, maybe even further.
And wasn't it also a city sort of rebuilding?
Yes, that's a really important point. They'd suffered a massive earthquake back in AD 62, quite devastating.
Yeah.
So right up until Vesuvius erupted 17 years later, they were actually in the middle of major reconstruction.
Okay.
Yeah, actively rebuilding and modernizing public buildings. We see evidence of impressive improvements to the Forum, the heart of the city, and construction work on new facilities like the central baths. So it's a dynamic place, recovering and evolving.
Okay, now let's shift focus. Turn our gaze just, 15 miles or so northwest to Herculaneum. You said smaller, wealthier.
Significantly smaller, yes.
Yeah.
Population estimates are maybe around 5,000. But crucially, it seems to have been a markedly wealthier town per capita. Think of it as less industrial, more residential.
Like a resort town, almost.
Exactly. Almost like the Roman equivalent of an exclusive high-end beach community today.
Yeah.
The architecture really tells that story. You don't find the same density of shops or workshops as in Pompeii. Instead, you find these incredibly luxurious private houses, villas really, like the House of the Alcove or the House of Aristides, built right down towards the sea. They feature lavish decoration, extensive use of colorful marble cladding, intricate mosaics, really expensive materials.
So definitely a place for the Roman elite.
It certainly seems that way. A seaside retreat. And there's even a traditional tale, likely a legend, linking its founding to the Greek hero Heracles, or Hercules to the Romans. It adds to that sort of prestigious, almost mythical aura.
Fascinating contrast. One, a bustling trade city rebuilding, the other, a wealthy coastal hideaway.
Precisely. And that difference in character is going to be reflected in how they face the eruption.
Okay, let's talk about the eruption itself. Because before we even get to the mechanics of the blast, you mentioned something that changes the whole picture. About the date.
Yes, this is fundamental. For, well, almost 2 millennia, the accepted wisdom, based on a surviving letter copy, was that the eruption happened in August of 79 AD. August 24th, usually.
Right, I think that's what most people still learn.
Probably. But modern archaeological consensus, based on a huge amount of evidence gathered on the ground, now places the date significantly later, on or more likely after October 17th. Some evidence, like a charcoal inscription found recently, even points possibly to October 24th.
Wow, October, that's a big shift, a whole different season. What kind of evidence could possibly push such a well-known historical date forward by 2 months?
It's actually quite compelling when you add it all up. First, the human remains. When forensic anthropologists studied the victims, they found many were wearing heavier clothing, thicker woolen tunics, cloaks, than you'd really expect for a sweltering Italian August heat wave.
Okay, that makes sense. More like autumn wear.
Exactly. Then there's the food. The foodstuffs found preserved in shops and homes are typical of late autumn, not summer. things like pomegranates, nuts, olives. Critically, summer fruits like figs and plums were found already dried or conserved, suggesting the fresh harvest was over.
Ah, I see. The state of the food tells you the season.
Precisely. And there's more. Fresh produce being sold was typical of October harvests. Also, the large clay jars used for fermenting wine, the dolia, had been sealed up. That was a task usually completed only towards the end of October, after the grape harvest and initial fermentation.
So, multiple lines of evidence all pointing away from August and towards late October.
Yes. The victims were dressed for autumn, the food available was autumnal, and agricultural cycles point to late October. It really changes our mental image of those final days.
It does. Cooler weather, maybe different activities happening. Okay, so late October, 79 AD. The mountain finally blows. How did geography and, crucially, the wind dictate who got hit first and how?
Absolutely critical factors. Pliny the Younger, who witnessed the eruption from a distance and wrote letters about it, described the initial phase. A massive eruptive column shaped like a pine tree, shooting miles into the sky, carrying tons of ash and pumice.
The iconic image.
The iconic image, yeah. Now, the prevailing winds on that first day were blowing strongly towards the southeast, and Pompeii lies southeast of Vesuvius.
Ah, so Pompeii was directly in the path of that initial fallout.
Directly in the path. It received the bulk of that first phase. For about 18 hours or so, Pompeii was subjected to a relentless rain of ash and lightweight pumice stones. Some quite large, apparently.
18 hours of that.
Yeah.
Sounds terrifying and deadly.
Terrifying, definitely. It caused roofs to collapse under the weight. But in a way, it was almost a mixed blessing. That pumice fall buried the city relatively slowly, under maybe 4 to 6 meters, about 13 to 20 feet of material.
Slowly being the key word there.
Exactly.
Right.
That time lag, those 18 hours of falling debris, crucially allowed the majority of Pompeii's population time to escape, to flee the city before the truly lethal phase arrived.
Okay, so many got out, but not everyone. What happened to those who remained?
Those who stayed behind, perhaps trapped in buildings or hoping to wait it out, were later caught by the next phase, the pyroclastic flows. These are fast-moving currents of superheated gas and volcanic debris. But the flows that eventually reached Pompeii, having traveled further, were somewhat less dense and had cooled slightly. Still incredibly hot, mind you, around 250 degrees Celsius, or 480 Fahrenheit. Hot enough to kill instantly, but different from what Herculaneum faced.
Right. Let's contrast that with Herculaneum then. It's west of Vesuvius, so the initial wind saved it from that pumice rain.
Initially, yes. Being upwind, Herculaneum only received a very light dusting of ash in the first 18 hours. Not enough to cause major damage. This might have given residents a false sense of security, or perhaps more likely prompted many to evacuate relatively calmly, heading towards Naples, perhaps.
But their luck ran out.
Dramatically. The fatal blow came later, in the early hours of the next morning, maybe around 1 a.m. The massive eruption column, unstable, finally collapsed under its own weight.
And that triggered the pyroclastic flows.
Exactly. It sent multiple, devastating pyroclastic surges racing down the volcano's western flank, directly towards Herculaneum. These weren't like the ones that reached Pompeii later. These were faster, denser, and hotter.
How fast and how hot are we talking?
Estimates suggest speeds of up to 160 kilometers per hour, that's 100 miles per hour, and the temperature was much higher, probably around 500 degrees Celsius, nearly 930 Fahrenheit. A succession of at least 6 of these surges hit the town.
6 waves of that. Unimaginable.
Utterly devastating. These surges didn't just deposit material, they slammed into the town, instantly incinerating everything flammable and burying Herculaneum completely. And much deeper than Pompeii.
How deep?
Under approximately 20 meters, that's over 65 feet of solidified volcanic material. Not soft ash and pumice like Pompeii, but a dense rock-like deposit formed as mud ash fused together. That depth and that material type are the absolute key to understand the different kinds of preservation we find.
Okay, that difference is stark. Pompeii buried under 4 to 6 meters of relatively soft ash and pumice. Herculaneum under 20 meters of rock-hard solidified flow. Let's dig into how that affected what survived. Pompeii first, the famous voids.
Right, the voids are fascinating. Because Pompeii was covered relatively quickly, but by finer, porous ash and pumice, this material packed tightly around objects and people. It hardened, creating a perfect mold.
A mold of everything.
Everything. Bodies, wooden furniture, doors, shutters. As the organic material inside the flesh, the wood decomposed over the centuries, it left behind a hollow space, an empty cavity, perfectly preserving the shape of what had been there. the void.
So it's literally an empty space that happens to be shaped like a person or a table.
Exactly. And the genius insight came much later, during systematic excavations in the 1860s. The archaeologist Giuseppe Fiorelli realized what these cavities were. He pioneered the technique of carefully drilling a small hole into the void and pouring in liquid plaster.
Ah, filling the mold.
Precisely. Once the plaster set, the surrounding hardened ash could be chipped away, revealing a perfect plaster cast of the victim, capturing their final posture, the folds of their clothes, sometimes even their facial expressions at the moment of death. It's incredibly powerful. Pompeii essentially captured the absence, the shape left by life.
It really is. Haunting is the right word. Okay, now Herculaneum. Buried deeper, hotter, faster. How did that lead to preserving wood and scrolls?
It's the intensity and speed of the heat from those pyroclastic surges. Instead of gradual burial allowing for slow decay inside a mold, the organic materials in Herculaneum were hit by that intense 500 degrees C heat wave almost instantly.
So they didn't decompose.
There wasn't time. They didn't rot, they carbonized. The intense heat rapidly vaporized the water in the organic material and turned the object essentially into charcoal, preserving its structure.
Like burning wood in a kiln almost.
Sort of, yes, but sealed instantly by the pyroclastic material packing around it. So we find carbonized wood everywhere. Roof beams, staircases, doors, window shutters, even furniture like beds and tables. We find carbonized food, loaves of bread, nuts, grains, even textiles, incredibly rare survivals.
And the scrolls, the library.
The famous papyrus scrolls from the Villa of the Papyri are the ultimate example. Hundreds of scrolls, tightly rolled, were carbonized in the same way, preserving texts that would otherwise be completely lost. It's phenomenal.
It really is. But you mentioned the excavation challenges. Herculaneum was found first, but harder to dig.
Yes, ironically, Herculaneum was stumbled upon first, way back in 1709, during the digging of a well. But imagine trying to excavate through 20 meters, 65 feet of solid rock. Early exploration was done by tunneling, essentially mining into the ruins. Incredibly slow, difficult, and dangerous work.
Right, not like just clearing away ash.
Not at all. Pompeii, rediscovered later in 1748, was much easier. Only 4 to 6 meters of relatively loose ash and pumice. You could do open-air excavations relatively quickly. That's a big reason why Pompeii became far more famous for centuries. It was simply more accessible.
That makes sense. Now let's talk about the people, the human cost. You mentioned the skeletons found at Herculaneum. That changed the story, didn't it?
Absolutely. For a long time, because initial explorations found relatively few bodies within the main town area of Herculaneum, the prevailing theory was that most residents had successfully escaped before the pyroclastic flows hit.
Which seemed plausible given the initial light ash fall.
Exactly. But that narrative was completely overturned in the 1980s. Excavations focused on the area of the ancient beach, down by the waterfront, and there, huddled inside arched stone vaults, probably used as boathouses or storage, they found them.
How many?
Over 300 skeletons, men, women, children, packed together, clearly seeking shelter from the eruption, waiting perhaps for rescue by sea. It was a shocking and poignant discovery.
And the state of those skeletons told a different story about the heat compared to Pompeii's victims.
A brutally different story. This is where the temperature difference becomes critically important for understanding the remains. In Pompeii, the 250 degrees C heat was enough to cause death, often by thermal shock or suffocation from the ash and gases, but it allowed the flesh to decompose later, leaving the voids for Fiorelli's casts.
Okay.
In Herculaneum, that estimated 500 degrees C heat from the pyroclastic surge caused something else entirely: instant death due to fulminant shock. The thermal energy was so intense and hit so quickly that soft tissues were essentially vaporized almost instantly.
Vaporized.
Yes. And the extreme heat caused violent muscle contractions, leading to the characteristic clenched hands and feet often seen in the skeletons. It was so intense it could even cause skulls to explode and bones to fracture post-mortem. That's why Herculaneum yielded actual fully preserved skeletons. The heat didn't allow time for voids to form. It incinerated the soft tissue immediately, leaving the mineral structure, the bones, intact but thermally altered.
That is incredibly grim, but scientifically fascinating. It explains why we have casts from one site and skeletons from the other.
Precisely. 2 different thermal pathways leading to 2 distinct forms of preservation of the human tragedy.
But those skeletons, horrific as their end was, now offer incredible insights, don't they, through modern science?
Immense insights. We can learn things Fiorelli could only dream of. For instance, recent chemical analysis, I think it was published in 2021, looked at the trace elements in the bones of the Herculaneum victims.
And what did they find?
Clear differences in diet between the sexes. Men, on average, seem to consume about 1.6 times more fish and seafood than women.
Interesting. Why would that be?
Well, it might reflect different occupations or access to certain foods.
Mm.
Perhaps men were more involved in maritime activities, or maybe higher status males had preferential access to expensive seafood. Women, on the other hand, showed evidence of consuming relatively more terrestrial animal products, meat, eggs, dairy, and also more fruits and vegetables.
So we're getting a detailed picture of Roman diet, broken down by gender, from people who died almost 2,000 years ago.
Exactly. It's that specific. They even identified one skeleton, number 26, found on the beach, as likely being a soldier, possibly a Praetorian guard based on his equipment found nearby. The thinking is he might have been part of Pliny the Elder's attempted rescue mission that sadly failed. It puts a potential face and story to one individual caught in that terror.
Incredible detail. Okay, let's move forward in time. Archaeology isn't just about the past. It's happening right now at these sites, isn't it? Especially in Pompeii.
Oh, absolutely. It's a very active field. While much of Pompeii was excavated in the past, there were still significant areas, particularly in the northern part known as Reggio V, that remained largely untouched, buried under the original eruption layers.
And recent work there has yielded some spectacular finds.
Truly spectacular. It's constantly reminding us how much more there is to learn. One of the most famous recent discoveries is the Thermopolium of Reggio V.
The snack bar.
Basically, yeah. An incredibly well-preserved street-side food counter, brightly decorated with frescoes of animals that were likely on the menu. And the amazing thing was, archaeologists found earthenware pots, the dolia, still containing remnants of the food being served on the final day.
Like what? What were Romans grabbing for lunch back then?
They identified traces of duck, goat, pork, fish, even land snails. It's like the cooks just walked away mid-preparation, an unparalleled snapshot of daily food culture.
That's amazing. And other big finds, too. I remember hearing about a chariot.
Yes, just outside the city walls, in a villa at Civita Juliana, they unearthed an almost perfectly preserved ceremonial chariot, a polentum. It's incredibly ornate, with bronze and tin decorations, likely used for parades or maybe weddings. It was found in a portico near the remains of horses, ready perhaps for an escape attempt that never happened.
And the art, are we still finding new frescoes?
Constantly. Recent digs in Reggio V have uncovered houses with stunning, vibrant frescoes that look almost freshly painted. Dining rooms with mythological scenes, Helen of Troy meeting Paris, Apollo pursuing Cassandra. Even a beautiful small shrine, a lorarium, decorated in a rare, rich blue color. The quality and preservation are just breathtaking.
It sounds like a golden age of discovery, but there's a flip side, isn't there? The conservation challenge.
A massive flip side. It's the huge, ongoing crisis for both sites. Once excavated and exposed to the elements rain, sun, wind, pollution, tourism, the buildings and artifacts start to decay, often rapidly.
So uncovering things can actually endanger them.
It's the paradox of excavation. Add to that problems like water damage from poor drainage, the sheer pressure of millions of tourists visiting each year, vegetation growth, and sadly, decades of past neglect and mismanagement. It's a constant battle.
I remember the collapse of that building in Pompeii a few years ago.
Yes, the Scuola Armatorum, the House of the Gladiators, in 2010. It was a wake-up call, highlighting just how fragile the site was. There have been other collapses, too. Herculaneum faces similar pressures, maybe even more complex given the deep excavation and water table issues.
So what's the approach now? Is it less about digging, more about protecting?
Exactly. There's been a significant shift in strategy in recent years. The focus now is much more on conservation, preservation, and stabilization of what has already been excavated. Major international efforts like the Herculaneum Conservation Project, largely privately funded initially, and the EU-funded Grande Progetto Pompeii, Great Pompeii Project, are tackling these issues head-on.
What kind of work does that involve?
It's everything from repairing ancient plumbing and drainage systems to stop water ingress, to stabilizing walls and structures, restoring frescoes using advanced techniques, managing visitor flow better, using technology for monitoring and extensive documentation. It's about ensuring these incredible sites survive for future generations, not just digging up more before we can care for what we have. It's a race against time, really.
A crucial shift. Okay, let's try and pull this all together. If we look back at our core comparison, Pompeii and Herculaneum. Same volcano, same day, vastly different outcomes.
That's the essence of it. Pompeii, buried relatively slowly under cooler ash and pumice, essentially throws life in place. It gave us those dramatic final postures, captured by the voids in Fiorelli's plaster casts. It's the archaeology of absence, in a way.
Herculaneum.
Herculaneum, hit by hotter, faster pyroclastic surges and buried deep under solidified rock, underwent instant carbonization. It didn't preserve the moment of death in the same way, but it preserved the physical materials of life itself. The wood, the food, the textiles, the scrolls, the actual stuff of the Roman world.
Two sides of the same catastrophic coin, yielding different kinds of invaluable knowledge.
Absolutely. Together, they give us an unparalleled window into the Roman world, from the grand scale of urban planning and elite architecture in Herculaneum to the detailed social fabric and everyday commerce of Pompeii. And now, even down to the specific diets revealed by the skeletons, they are endlessly revealing sources.
And that brings us to a final thought, something really provocative for you, our listener, to consider focusing back on Herculaneum, the villa of the papyri.
Ah, yes, the library. Believed to contain the only ancient library to have survived largely intact from the classical world. Hundreds, potentially thousands, of scrolls buried within its unexcavated sections.
But reading them has been almost impossible, right?
For centuries, yes. The problem was the ink. Ancient ink was typically carbon-based, essentially soot mixed with water or gum. When the papyrus scrolls themselves were carbonized by the heat, you ended up with carbon ink on carbonized papyrus.
Making it invisible to normal imaging, even X-rays.
Exactly. X-rays pass right through both, similarly. For decades, it seemed like a scientific dead end. Attempts to physically unroll the brittle, charred scrolls often destroyed them. Many thought the texts were lost forever.
But technology has moved on.
Dramatically. Recently, using sophisticated techniques involving particle accelerators, high-resolution CT scanning, and crucially, artificial intelligence trained to detect subtle differences in surface texture or density where the ink was applied, researchers have started to read inside the rolled-up carbonized scrolls without physically opening them.
AI is reading the scrolls.
Yes. The Vesuvius Challenge and international competition spurred huge progress. In early 2024, teams successfully used AI to decipher hundreds of words, entire passages from one of the scrolls, revealing parts of a previously unknown philosophical work discussing pleasure. It was a massive breakthrough.
Wow. So, considering the sheer volume of scrolls known to be in the villa, many still completely buried and unexcavated, what comes next?
That's the provocative question, isn't it? If this AI-driven technology can be refined and applied to the hundreds, maybe thousands of scrolls still waiting in the villa of the papyri, what monumental lost knowledge might we unlock?
Lost plays, histories, scientific treatises, philosophical dialogues we only know by name.
Potentially all of that and more. Could we recover lost works by Aristotle, Sappho, Epicurus? Entire fields of ancient thought, known only through fragments. The secrets of the ancient world, locked away by Vesuvius's fire nearly 2,000 years ago, might finally be readable, not through picks and shovels, but through pixels and algorithms. What will they tell us?